All right, let's look at example 7. Example 7, they say that rewrite the following sentence in first order language. All right, so guys, your task is you write from natural language, you convert to first order language. Then you need to negate. You need to write the negation in first order language, and then you convert that to natural language. So I give you in English, you need to convert to predicate, then you need to negate the predicate, and then you need to write your final answer in English. Guys, be careful with this kind of example, because I always ask stuff like this, all right? For you to write first order, negate, then give me back in natural language, all right? As I mentioned before, first order language, think of predicate, so stuff like this. Quantifier, predicate symbol, predicates, and so on. If I talk of natural language, I'm talking of English, all right, just English. All right, and the statement there is no politicians are honest. It's a nice one. No politicians are honest. So how would you do this? So the easiest way, because I said no politician, like I said before, it becomes a little bit difficult to choose between universal and existential. No politician, me, I'm generalizing, all right? I'm saying that there is no politician that is actually honest. So you need to start by saying that for all x element of P, where capital P is the predicate symbol, is a politician, all right? So when you say for every x element of P, you're saying that all politician, and then this predicate you can define it as X is honest, all right? But you see, I'm negating it. It means that all politicians are definitely not honest, all right? So they're not honest. Once you do that, I ask you, the second step is you need to write a negation in first order language. So you need to negate this statement. You need to negate this. Now to negate this, like I said, you only, for the first bracket, you only negate this quantifier. So from the universal, it becomes existential, all right? Don't touch the P, just leave the P, all right? You only change the quantifier. For this second bracket, you're going to have not, all right? And double negation cancels off. So if you have not, H, H is just equivalent to H, all right? So if you have not, H is just equals to H. So these two, they're going to cancel out each other. So double negation is just H of X. Now, how do we write this in natural language? So you need to write the answer back in English. So you're going to say some. Remember, this existential is some, all right? Or there is at least one. So in this case, some politicians are honest, all right? Although in this case, we can't even point to one that we actually know, but we agree that some politicians are honest, all right? Let's look at example 8. All right, for example 8, they say, write down the negation of the following universal quantified conditional statements. All right, this one is a true test of understanding. I just need to see the negation of this statement. Now let's start with the first one. To negate this, obviously you're going to add a negation sign outside there. And to negate this statement, you go block by block. We start with this red block there. When you negate this red block, you say that from universal, it becomes existential. That is all that actually changes. All right. Universal becomes existential. Now to negate the second block, I'm just going to change the color. You also need to negate this. So to negate this, we'll go step by step. So if you remember well, the reason why this one is a very tricky one is that you can't just negate it directly. You need to first of all consider the fact that if you have P implies Q, this is logically equivalent to not P or Q, all right? So it's logically equivalent to not P or Q, all right? So because of this logical equivalence, it means this whole thing in green can be written as this here, all right? And if X squared, so indirectly, what I'm trying to say is I can rewrite this whole statement in green as Okay, not P means I need to negate this first one. So I'm going to have X squared is actually less than or equals to 1. All right, so I have is less or equals to 1. And then I have or X is greater than 0. All right, so that will be your first step. You need to start by converting. You need to get rid of the implication sign, because if you don't get rid of the implication sign, your negation is going to be completely wrong. All right. There's a very big chance that your finance is going to be wrong. So your first step before you even start negating is to get rid of the implication sign. So please always make sure that you get rid of the implication when you're trying to negate. It makes your life so easy. All right. So now we're happy with doing this. Now I need to go ahead and negate this now. So for the negation, so if I have to negate this whole statement, this first piece here becomes existential. So universal changes to existential. So you say there exists an X element of real number. So there exists a real number. And then how do you negate this piece here? The negation of X squared is less than or equals to 1. It's just X squared is greater than 1, right? So if you negate that, you get X squared is greater than 1. If you negate or, you get and. You see why I have an and. Now, if you negate X is greater than 0, if you negate that statement, you get X is less than or equals to 0. All right. So please don't skip this step here. Make sure you get rid of the implication and then negate a step. Now there's a little trap here, guys. When you're negating this first piece here, always focus on the quantifier. Please just focus on the quantifier. Some people, I will say that, let me just write a nice example. I've seen this a lot in the past. For all X element of, now I say Z plus. All right, so I use Z plus. And then they have to, and then obviously have some statement there. Some people in the process of negating this, they negate this quantifier, and then they also try to negate Z plus to Z minus. No, all right. The negation of for all is just for some. It doesn't change the domain, all right? Your domain is not affected by your negation, all right? So if my domain is a set of real numbers, after negating, I'll just end up getting a real number, all right? It doesn't change. If it's positive real numbers, it will still end up as positive real numbers. So the only thing that changes is, are we talking of the whole set of positive real numbers? Are we looking at a specific real number, or for some, a subset? You understand? That's why I say you only focus on that universal quantifier or the existential quantifier. All right. Don't try to negate your domain. All right. Because the negation of real numbers is anything that is not real, which obviously is complex. And you need to be careful, because some complex numbers are still real. So I will never want to make your life so complicated. So just negate the quantifier and then move to the other bracket, negate piece by piece. All right. That's basically the last example. Is there any question from your side? You can ask your questions. Any question? All right, someone says to repeat the last example. All right, you got lost. Okay, let's repeat this. We have enough time. So what I said is, write down the negation of the following universally quantified conditional statement. All right. Why is this a universally quantified conditional statement? Because we're using the universal quantifier. So it makes it a universally quantified conditional statement. To negate this statement, you need to observe carefully. You're dealing with implication. There's no direct negation of implication. So you need to start by writing the logical equivalence. So your first step is to say this statement is logically equivalent to, you say there exists for all real numbers, because this is universal, say for all, actually, for all real numbers. Now, I told you guys before, if you have A implies B, you can write it as not A or B. So it's not the first statement or the second statement. So not the first statement, instead of X squared is greater than 1, it becomes X squared is less than or equals to 1. So that will be the negation of this first statement there. And then we need to say or the second statement there. All right. I hope everyone is happy with this logical equivalence. So I'm just rewriting this, but I'm just getting rid of the implication sign. If you're still confused why this change from x is greater than 1 to x squared is less or equals to 1, is because I said if if I have a statement A implying a statement B, we say is logically equivalent to not A. You see, I need to negate the A, and then I need to say or B. Remember, or there is a union actually, and it's an intersection. In this case, we say not A or B, so not A union B. All right. So hence, you understand now why we move from x squared greater than 1 to x squared is strictly less or equal to 1, because we need to get rid of implication. You need to negate the first statement, and then you say or the second statement unchanged. Now I need to go ahead with my negation process. I need to negate this whole statement. We need to negate this. But how do we go about doing that? We go step by step. We start by negating this piece here. What's the negation of for all x element of real number become for some real numbers? So universal changes to existential. So upside down A changes to the E facing the wrong direction. All right. So universal just changes to existential. All right. Like I said, please don't try and negate your domain. So your set of real numbers remains your set of real numbers. All right. Now we need to negate this second bracket here. So this whole piece here. All right. We need to negate x squared is less than or equals to 1. What's the negation of that? If x squared is less or equals to 1, the negation is just x squared is greater than 1. All right. And if you negate this one, if you negate or, what do you get? You get and. You see how we get and. And if you negate x is greater than 0, all right, the negation of x is greater than 0 is x is less than or equals to 0. Guys, this example, I'm just going to put close that. This one is so important, all right? Because I've seen it many times in the past, not exactly the same question. I've asked a question that looks like that in the past. And people tend to give me this without actually adding this equality there. All right. So the negation of x is greater than 0 is x is less than or equal to. All right. I'll just do another example on the side. If I say x is less than b, and I want to negate the statement, so I ask for the negation. Obviously, the negation of that is going to be not A. If you negate less than, what do you get? Greater than or equal to, very important, or equal to, not B. All right. I hope that's clear enough. I'll give you another example, just so that we're all on the same page. Let's say now I ask you for the negation of not A is greater than or equals to B. All right, let's see if we're good with this. The first, you're going to have not A, double negation. We say that the negations disappear, right? So not A is just A. What is the negation of greater than or equals to? It's strictly less than. So the equality part goes away. And the negation of B, just have not B there.